This video is going to start looking at several of our trig identities, and I'm going to start off with our reciprocal identity. And we've mentioned this a little bit with our sine, cosine, and tangent. For example, we know that if we have the sine of theta, initially we said that sine of theta, that's going to be equal to y over r, and then we said that that would be the reciprocal for the cosecant. So therefore, we said that the cosecant of an angle then would simply be equal to r over y. Now, instead of thinking of it this way, looking at the actual identity, then the same thing would state that if we have the sine of theta, that's going to be equal to 1 over the cosecant. And then if we take and have the cosine, that's going to be equal to 1 over the secant. And then if we look at the tangent function, the reciprocal of the tangent we said was cotangent, so that would be 1 divided by cotangent. And we could also state this the other way. In other words, if we are given, so if you know these three, the other three will be the same way. We could state it as the cosecant of theta, then that would be equal to 1 over the sine of theta. Or if we had the secant of theta, that would be equal to 1 divided by the cosine of theta. And then, of course, the cotangent would be equal to 1 over the tangent. And again, that's true because they're simply reciprocals of each other. So it's either way you can write it. So really, if you can memorize these three, then of course the reverse is going to also be true as well. So it looks like a whole lot to memorize, but all we have to memorize is that your sine and cosecant are reciprocal. So sine is 1 over cosecant, or cosecant is equal to 1 over the sine. And depending on the situations, depending on which way you're going to use this. For example, if you're ever solving a problem, and let's say that you get to the end of a problem and your final answer, something you end up with is 1 over the sine of theta. And if you want to eliminate the fraction so that your answer, if this is your answer here, 1 over sine theta, to eliminate the fraction, then we could say, well, that's the same thing as cosecant. So you could replace this by simply writing this as the cosecant of theta. And this way, this expression looks a lot nicer than 1 over sine theta. And if you go the other direction, for example, in the past we were looking at if we were given a problem and you want to find the let's say cosecant, for example, of let's say a 20-degree angle, then of course we kind of use the idea here of using the calculator. We would see on the calculator that we don't have a cosecant button, so we could use the calculator by typing in 1 divided by the sine of 20 degrees. So if we go to the calculator, once again, we want to make sure that our calculator is in degree mode. So I need to go down here and highlight degrees. And now if I want to look at 1 over the sine of 20, that would give us the cosecant of 20. So I would type 1 divided by the sine of 20 degrees. And there we end up with the answer. So this is just kind of quickly reviewing how we could use these reciprocal identities. And a little bit later on in the next chapter, when you get into chapter 5, we're going to talk more about these identities. So at this point, I'm really just trying to introduce to make sure you start understanding the reciprocal identities. All right, the next set of identities we have are called the cofunction identities. And this is where the cofunction identities, you kind of have the sound of your trig functions. I know a lot of times I used to always think, and you probably think, well, the tangent and cotangent up here, tangent, cotangent, it sounds like they're reciprocal, but you would kind of think secant and cosecant might go together, or sine and cosine go together. But that's not true for these reciprocal identities. But where the sound of secant, cosecant, sine, cosine tangent, cotangent, where that comes into play is when we look at the cofunction identities. And what we have here is, if you think of this word cofunction, you can almost think of this as complement. And we have the sine of theta is going to be equal to the cosine of, let's say, a 90-degree angle minus theta. So what that means is when we say theta and the cosine of 90 minus theta, we're saying that theta and this 90 minus theta are complementary angles, which means they add up to 90 degrees. So what this is indicating, and I'll show you in just a minute, is that if we had the sine of, let's say this was a 30-degree angle, then 90 minus 30, that means we would take the cosine of a 60-degree angle, and they would actually be the same answer. The sine of 30, the cosine of 60. So this is where this sine cosine, the cofunction identities come into play. Okay, and I'll go into more detail in just a second here, but then we would also have secant theta, and that would be equal to the cosecant of 90 minus theta. And then, of course, tangent would be equal to the cotangent of your 90-degree angle minus theta. Now here I'm using degrees. Of course, if we were in radians, then instead of 90 minus theta, you would replace this with your pi over 2 for the 90 degrees. Okay, but I'm going to use degrees for right now just as a reference so that we can understand these cofunction identities a little bit better. So let me think of looking at this 30 and 60-degree angle again. The idea is that the sine of 30 is equal to cosine of 60. Or if I said the sine of 20, that would equal to the cosine of 70, because 20 and 70 add up to 90 degrees. Now, if we think of this in terms of a right triangle, we probably can visualize this even better. Whereas if we have here a 30-degree angle, we know that this angle up here at the top must be 60 degrees. So if we think of this as a 30-degree angle, and I want to take the sine of a 30-degree angle, and I'm going to use the right triangle trig here to think about this. I'm going to think of this, the sine function of 30. This is looking at, remember, the opposite over the hypotenuse. So if I'm using this angle 30 degrees, that's going to mean this is the opposite, and this side is the hypotenuse, and this would be the adjacent side. Okay, and I'm going to go ahead and fill in and think of this as the unit circle. I'm going to fill in our numbers for us. So we know that this is going to be, from the unit circle, square root of 3 over 2. This is going to be 1/2, and of course the unit circle, that means here the hypotenuse is equal to 1. So if I apply the opposite over hypotenuse, and again you could think of this as, instead of opposite hypotenuse, we can think of y over r. This is going to be 1/2. This would be equal to 1/2 divided by 1, which would simply be equal to 1/2. Now, what the cofunction identity up here states, it states that if I was to have the cosine of 60 degrees, okay, now you got to be careful. That means if we look at the right triangle, we're looking at this angle now. So if we're looking at the 60-degree angle, this side down here at the bottom of the triangle has become the opposite side, and this side over here is the adjacent side. Okay, and of course this is still the hypotenuse. So if I take the cosine, which is the adjacent side, so now here the adjacent side, we're looking at cosine is adjacent over hypotenuse. So the adjacent is 1/2, so it's 1/2 over 1, so we get the same answer of 1/2. And I think it's easily determined this from looking at your triangle that this 30 and 60 are your complementary angles, and that's where this idea of your cofunction's coming from, because if we're based off of the 30-degree angle, this is the opposite side over here, but if it's based off of the 60-degree angle, that becomes the adjacent side. So we're both looking at the sine of 30 and the cosine of 60 is both based off of this 1/2 over the hypotenuse of 1. Okay, and of course here this would be true if you were looking at radians instead of degrees. You would just be using the power over 2 instead of the 90 degrees. All right, so the next set of trig identities that we have would be the quotient identities. And that's where if we look here, we're looking at the tangent of an angle. And notice here we said before tangent is equal to y over x. And we said the cotangent of the angle would be equal to x over y. Now, if we look closely, we also said that the tangent of an angle with being y over x, what did we define as our y? Well, if we think about our trig functions, wasn't that our sine function? So that would be sine of theta. And when we had x, that was our cosine function. So we would take sine of theta divided by cosine theta. So if you take the sine of an angle divided by the cosine of the angle, that's going to give you your tangent. And the same thing over here would be true for the cotangent, except for here, cotangent x over y, well, for the x, for the cotangent of your angle, our x would be cosine, so that's cosine theta, and the y is our sine function, so that would be divided by the sine of theta. So really what we're thinking of here for your quotient is tangent is equal to sine over cosine, cotangent is equal to cosine over sine. And again, tangent y over x, sine over cosine, cotangent x over y, cosine over sine. So that would be representing our quotient identities. And we can even verify that with the calculator. If I was to type in, for example, the tangent of, let's say, an angle of, we'll use 30 degrees, and tangent of 30 is 0.57735. Well, if we were to take the tangent, which would be sine over cosine, we could take the sine of 30, make sure you close the parentheses, divided by the cosine of 30, and notice we get the exact same answer. And that's because of this particular trig identity. All right, so make sure that you understand and memorize these reciprocal identities. Sine is 1 over cosecant, cosine is 1 over secant, tangent is 1 over cotangent, or you could state it just the reverse. Cosecant is 1 over sine, secant is 1 over cosine, cotangent is equal to 1 over tangent. And also you want to start becoming familiar here with the cofunction identities, where this is the sound of the function kind of pairs up sine, cosine, secant, cosecant, tangent, cotangent. And again, later in the future, we'll look at some examples where we're dealing more with these cofunction identities. And of course, also you want to memorize here the quotient identities for the tangent and cotangent, where you have sine over cosine and cosine divided by the sine function.